All right, so we have reached the review sheet for Unit 3 with the periodic table. I'm going to explain my answers to these questions. Definitely anything I write, you should write. I'll try to be really clear about things that I think are the most important. We'll answer these together, and then just make sure that you have all your answers and explanations copied down onto the worksheet for this. And get ready for the exam tomorrow in whatever other ways you think are most beneficial to you, whether that's watching videos online or reviewing your notes. So without further ado, which of these elements is the best conductor of electricity? So they're talking about metals here. And you can find metals on the bottom left-hand side of the periodic table. Nickel is a metal, although it is in the sort of the middle of the table under transition metals. Number 2, the element in period 4 and group 1 of the periodic table would be classified as A. So actually anything in group 1 is going to be considered a metal because group 1 are the alkali metals. Therefore, the best answer is choice 1. Number 3, which of the following group 15 elements has the greatest metallic character? So metallic character increases as you move down the table. Therefore, whatever element in this list is in group 15, but also at the bottom of group 15, will be the answer. So I'm looking at my periodic table now, and I see bismuth is at the very bottom of group 15, so I'm going to choose bismuth. 4, which element has properties of electrical conductivity and luster? So when we have electrical conductivity and luster, they're talking about a metal, but it also exists as a liquid at STP. So then now we're talking about a liquid metal, which makes it mercury. And the best answer is choice 1. Number 5, properties of nonmetal atoms include, so all of these are about ionization energy and electronegativity. So what I would say is that ionization energy increases as you go up and right on the periodic table. And electronegativity also increases as you go up and right on the periodic table. So what's up and right on the periodic table? That would be the nonmetals. So properties of nonmetal atoms include high ionization energy and high electronegativity. Number 6, which element is a noble gas? Finally, an easy one. It is krypton. I can find that in group 18 on the periodic table. Germanium is classified as a metalloid because it borders that staircase that you'll find on the periodic table. Number 8, which element has chemical properties that are most similar to those of calcium? So what I would say is that properties of elements are really, really similar if they're in the same group, and that's because they have the same number of electrons in their valence shell. So since calcium is in group number 2, I just need to choose another element that's in group 2, and that would be strontium. Number 9, which statement explains why ozone gas O3 and oxygen gas O2 have different properties? So ozone gas has 3 oxygen atoms bonded something like that, and oxygen gas has 2 oxygen atoms bonded something like this. And they have very different properties, and that's because they have different molecular structures. Number 10, base your answer to the following question on the electron configuration table shown below. And they want to know what's the total number of valence electrons in an atom of electron configuration X. So the valence electrons are just the electrons in the very last orbital. So my answer to that is officially just 2. And also one of the things they just noticed, which wasn't asked, but when I see this 2873, The 7 and the 3 are telling me that element Y is excited. And I know that because you can fit 8 electrons in this third orbital right here, but right now we only have 7, so this one of these electrons in the fourth orbital should be moving down to the third. Number 11, in which shell are the valence electrons of the elements in period 2 found? So elements in period 2, they include elements like lithium, whose electron configuration is 2,1, and it also includes neon, whose electron configuration is 2,8. The valence shell is the second orbital for both, and this is not a coincidence because both of these elements are in period 2. So the period that you're in also tells you what shell contains the valence electrons. When an atom becomes a positive ion, the radius of the atom decreases. And the reason for that is because when atoms become positive ions, they have to release electrons, and that also releases an orbital, and that's going to make the atom smaller. Number 13, aqueous solutions of compounds. First of all, what does aqueous mean? Aqueous means that you have been dissolved in water. Now going further from there, it does reference that some compounds containing element X are blue when they're dissolved in water. You should know that transition metals, or elements in groups 3 through 12, those are the ones that are going to have the most colorful ions when they're dissolved in water. And that means that the element that we're looking for is going to be copper. Because of the 4 choices that you were given, copper is the only one that lies in the transition metal band. 14. As the elements in group 17 on the periodic table are considered from top to bottom, what happens to the atomic radius and metallic character? So as you go from top to bottom, atomic radius increases as a result of an increase in the number of orbitals, and metallic character increases as well. So I'll write that in. So using that logic, the best answer is 1. So number 15, an atom with the electron configuration of 282, and they want to know what's most likely going to happen to it as it becomes an ion. So what I would say is that it's really all about those last 2 electrons, and it's going to be what the atom's going to need to do in terms of strategy to get a full valence shell. And the easiest thing that this atom can do is to release 2 electrons. So when it does that, it's going to make the overall charge of the atom, the net charge of the atom, is positive 2. Again, it's like you're losing negatives, so losing negatives gives you a positive charge. And as you're releasing those electrons, you've also just released an orbital, so the atom is going to be much smaller as well. Therefore, my best answer here is decrease in size as it forms a positive ion. 16. Which of the following elements has the strongest attraction for electrons? Finally, an easy question. Strongest attraction for electrons is code word for electronegativity. And furthermore, electronegativity increases as you go up and right on the periodic table. So I'm going to choose the element that is furthest up and right of all the ones that I've been given. And the best answer for this one is going to be oxygen, which is the furthest up and right of the elements that I was given. So number 17 is very similar. It says, which group 17 element has the least attraction for electrons? So again, they are talking about electronegativity, but this time they want the lowest electronegativity. So since electronegativity increases as you move up and right, then it decreases as you move down and left. And therefore, I can't move left inside group 17 because group 17 is a column, but I can move down. So whichever element is the furthest to the bottom within group 17 is also going to have the lowest electronegativity. And of the ones that I'm given to choose from, iodine is the lowest towards the bottom. Number 18, it says, as the elements in period 2 are considered in succession from left to right, so we're looking at a period, and we're going from left to right, there is a decrease in atomic radius with an increase in atomic number. And they want to know an explanation for that. So we start over here in period 2 with lithium, whose atomic number is +3, and we end with neon, whose atomic number is 10. So that explains their atomic number, but there's also a decrease in radius. So lithium is large radius, and neon is small. So since lithium and neon both have the same number of orbitals, since they're in period 2, they both have 2 orbitals. And that makes them sort of similar sizes, but what's going to really make the difference here, the reason why neon's going to be smaller, is because neon has more nuclear charge. So it has more protons in the center, and more protons are drawing those electrons in, which will make its atom small. But the reason why these two compare so well is because they both have the same number of orbitals. So when it asks me, this may best be explained by the fact that I would say number of protons increases is correct. So it could be 1 or 2. But it has to also say that the number of shells of electrons remains the same. So my best answer is number 1. Number 19. It says when an atom of phosphorus becomes a phosphide or P3- ion, first of all, if it's a 3-, that means that you gained 3 electrons. And gaining 3 electrons is going to increase the amount of repulsion that you find in the electron cloud, and that actually, as a result of the increase in repulsion, the electrons will spread out, and that will make the atom larger. So the best answer here is that when an atom of phosphorus becomes a phosphide ion, the radius increases. Also, I just remembered to say something. When you see the ending IDE, although it's starting with phosp, just like phosphorus starts with phosp, the IDE ending, it means something. It means that it's an ion, and it means that it's negative. So negative ions end in IDE. So we just take the element name and drop the last few letters and then add an IDE. So if you see something like hydride or nitride or oxide or fluoride or chloride, if it ends in IDE, then it means it's an ion and it's negative. Number 20, the element in period 3 that has the highest first ionization energy. Remember, period 3 is going to be going left to right, and the one that's going to have the highest first ionization energy will be on the right. And the reason for that is because ionization energy increases as you go, let's see, up and to the right. So we're going to choose the one furthest to the right, and that's going to be, of course, the element that's in group 18. 21, explain in terms of electron configuration why selenium and sulfur have similar chemical properties. So you can find selenium, which is Se, and sulfur, which is just S, in group 16. And while elements in the same group do have similar chemical properties, if I stop here, I have not answered the question. And the reason for that is because I need to answer in terms of electron configuration. So what these two elements have together in terms of their electron configuration is that they both have 6 electrons in their valence shell. So it's this last part of my answer that makes me right. 22, it says explain in terms of atomic structure why the atomic radius of iodine is larger than the atomic radius of fluorine. So iodine and fluorine are similar because they're both in group 17, but fluorine is at the top and iodine is towards the bottom. So in terms of atomic structure, the reason why iodine is larger is because it has more orbitals. Okay, next question. It says, explain in terms of atomic structure why cesium has a lower first ionization energy than rubidium. So we have cesium here at the bottom and rubidium right above it. But we want to know in terms of only atomic structure why cesium's first ionization energy is lower. The reason for that is that cesium and rubidium have different numbers of orbitals. Cesium, I believe, has 6 orbitals, whereas rubidium has only 5. So the extra orbital in cesium is going to make the atom larger, and the larger radius is going to make the ionization energy lower. And lastly, in number 24, it asks me to state the trend in first ionization energy for the elements in the table as the atomic number increases. So first ionization energy increases as you go up and right on the periodic table. So I just recorded that here. I said ionization energy increases up and right. But this is, if you were to say that as your answer, you would have made the most common mistake when answering this question, because it actually just wants you to state the trend in first ionization energy for the elements in the table as the atomic number increases. So that means that you're just stating the trend in first ionization energy going from top to bottom within the table, because we have atomic number increasing as we go top to bottom. So all you need to say is one word, and you just say decreases. Number 25, which trend appears as the elements in period 3 are considered from left to right? So as we're going from left to right within period 3, a few things happen. You're going to get an increase in ionization energy. You will generally get an increase in electronegativity as long as you don't include the noble gases. So I'll say except group 18. You'll also get a decrease in metallic character. So with those 3 things, we can answer the question. So if you're going from left to right, metallic character will decrease, so it could be 1 or 2. And electronegativity will increase generally. But remember, exception is noble gases. So that brings us to the end of the Unit 3 exam review sheet. You can check my answers here. This is the answer key. And good luck studying for the exam.